Welcome, grade 9s. Today we're going to look at unit 7.5, the lesson on reflections and line symmetry. So what we want you to do today is we're going to get you to draw and classify shapes with what's called line symmetry. Now we did this back in grade 4, so I don't expect you to remember it, so let's go over it just a little bit so you can get a sort of a refresher on it. Okay. The definition of line symmetry is a line, like this one right here, the dashed one, that divides a shape in a way that if I were to fold this over, it would match perfectly. We would call that, it has line symmetry. It's symmetrical. The two sides are symmetrical. And you could see that this is one for this one. Now there's no other way to do that on here. You try to go this way, and then if you try to fold it, it's quite obvious that this one right here, as this one goes over to this side, there's no corner here to match this corner here. So it can't be folded that way. And likely also, if you try to go this way, as this comes down perfectly 90 degrees, it's going to come out to here somewhere, and there's no corner there either. So the only one is the one that I've got right here. Take this one out. All right, so let's take a look at some signs and some shapes here. Now, I'm going to do the first one with you, and then we'll let you do the next one. All right. For this one right here, you take a look at the triangle, and you want to find out where can you put the lines such that it would actually allow it to fold over. Now, to do it here would cause a problem because there's a point here that would go straight across, would come out here. There's no point there to match it. So there's no way this tiny triangle is going to lay on top of this trapezoid and make it match perfectly. So this one here is not a line of symmetry. But if I were to take the line of symmetry and I were to cut it down here, now this can fold over to here, and the whole thing, there's a right triangle here and there's a right triangle here. These two are exactly the same. Fold them in half, I'll have just this complete shape right here. Right? I can do the same thing if I were to go up and down, and because this is a equilateral triangle, this side over here will flop over to there and match it perfectly. And of course the other one would be to go right through here, and that would mean that the top part over here, I guess you'd say, right there, would fold over and match here. So this shape here, this triangle, has 1, 2, 3 lines of symmetry. And if I was marking this, you'd get 3 marks for it. Now, there's one here, and there's one here. Now, don't worry about the colors. Just do this regardless of the colors, all right? So assuming that it's just all yellow or something. So pause the recording and finish this, these two right here. All right, so first off, let's get rid of this stuff here. I've got it already set up. So there's the one that we just did. Now this one right here, you'll notice that there's only 2 lines of symmetry here, and that is this way and that way here. All right. If I try to go on the angle here, like this, all right, you'll notice that when this folds over, it's going to come over to this side, and there's no fold there. And same thing with this one. It's going to go across this 90 degrees. It's going to be over here, and there's nothing there. So having the one here, or even the one that goes from there, these ones don't fold. All right, that would come over to here. There's nothing there to match it. All right. So take a look at that one. That one's done. There's only one vertical and one horizontal. And the next one over here, this one here has got a plus sign in the middle of it, or an intersection sign. And you can see that I could put a line here, and then that would fold over. I could put a line here, and this rectangle would fold onto that rectangle. I could put a line on the vertical, and this side here will fold over on that side. So in this case, I've got 1, 2, 3, 4 lines of symmetry. All right. I want you to take and do these 3 right here. So pause the recording and take and try and put in the lines of symmetry for these 3. Okay, so let's take a look at this one right here. Right? If I were to take and put a line up and down there, that part of the exclamation mark would match that. This side of the dot would match that. This side of the triangle would match that. Everything would go well. There's no way I can go this way or that way, so this is the only line of symmetry that's possible here. Now on this one, you can go straight up and down. You can also go on a sideways angle here. Now the question is, can you do this? And if you notice, that will flip over to here, so yes you can. And of course this one here will allow that rectangle on this side to come over to this side here. So this particular shape has 1, 2, 3, 4 lines of symmetry. Now, over here on this tractor, there's no symmetry at all. There's no way you can cut this so that it would allow part of this to fold over and actually match perfectly. So this particular one here, it has no lines of symmetry. So there's 0 lines of symmetry here. Now, this one over here, pause the recording, and I want you to do these 3 right here. Okay, now, in order to make this work, let's take a look at this one right here. I can put a line of symmetry right here, and that will fold over here. I could put a line of symmetry here, and this would fold over there. I could put a line of symmetry here, and this would fold over, sorry, this side here would fold over that. I could do a vertical one, and this side here will fold over those. But because it's a circle, this one also works. And this one here 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 also works. And I can keep adding lines in here. Right? If the lines are too big and you have a problem, I can just go back and just start putting in smaller ones. Right? But eventually this is all going to turn black. I could make this such a small line that I could put in hundreds and hundreds and hundreds of these lines of symmetry. Because this has got an infinite amount of possibilities, this one has an infinite amount of lines of symmetry, and that's what we call the line of symmetry. That's the infinite symbol right there. Now taking a look at this one over here on the pentagon, I can take this and go there. I can take this and go there. I can take this point and I can go there. I can take this point and I can go there. Right? I cannot go and put one here because this will not fold over here and match anything over there. Remember, it's got to go perpendicular to this, so it's going to come out to here somewhere. So this last one I put in, that one does not belong there. So this has 5 lines of symmetry. Okay. Now, taking a look at this one right here, we know that there's one going to go down the middle because this side will flop over and match that side perfectly. But that is the only line of symmetry that you can have. There's no other way to put one in. If I go this way, then this small box is going to come down here, and it's not going to match this wide open one out here. So this one only has one line of symmetry, and that one's there. Okay, pause the recording and do these 3. Okay, let's start with the hexagon. Okay, the hexagon, obviously, going up and down works, right? Going straight across works. We could go this way, that would work. We can go this way, that would work. And what about this corner to that corner, right? Doesn't actually look very good, but that's a possibility. From this corner here to that corner. So I've got every flat and every corner taken and counted for. So I've got 1, 2, 3, 4, 5, 6. Don't count this one because we already counted it there. So this one, 6 lines of symmetry. Now over here on this one, we've got one going up and down here. That's true. We got one going that way. We also have one going this way and one going this way. So this one here has 4 lines of symmetry. Now the moose sign is just like the tractor sign we had. There's no way that you can cut this in any way so that the thing will fold over. If you put it this way, what's going to happen is you're going to be looking for antlers over here, which these antlers will actually match to. And since they're not there, you cannot do it that way. So this one here, again, like the others, this one has 0 lines of symmetry. All right. Now, some of the things you have to understand when doing lines of symmetry, you heard me mention that you have to have a perpendicular to the line of symmetry. So I want to take a look at this little object right here, okay? If I were to take and draw this, all right, and it's complicated, looks like a head on top of a box, what you should have noticed is the distance from here to here is 90 degrees, right? See the 90-degree angle right there? Right. Now, then this distance from here to here, if this is done correctly, you notice I've got 3 prime marks here and 3 prime marks there. That means that this distance and this distance are equal. So AD, and of course this is going to be on the other side. If I've drawn it, it would be D prime That's the new one. All right, and A prime. So we know that this distance and that distance have to be equal. All right. Now B to E, all right, and this is also E prime when you draw it. So BE equals B prime E prime, and it has to be at 90 degrees. This is F prime right here. So CF has to equal C prime F prime. Now in this situation, what I would have probably done for you is I would have told you that I want you to draw, here's your line of symmetry, draw it. And that would mean that you'd have to go past this 90 degrees to get to here. Past this 90 degrees to get to here, and notice the distances are the same. Now, in this situation, I've got more than one component here. I've got hexagons, and I now have 7 of them. 1, 2, 3, 4, 5, 6, 7, and they make another pattern. So what I want you to do is I want you to take a look at this, and I want you to use this as a whole unit, or a whole drawing, and I want you to put the lines of symmetry on that. All right, so what we're going to do is we can take this out, and here is my lines of symmetry. There's one there, there's one there, and you can see them all drawn in there. That gives me 1, 2, 3, 4, 5, 6. Can't count this one because I already did. So this one here has 6 lines of symmetry. Okay, I want you to draw the lines of symmetry on this table. Okay, so now this is going to look like that. So you'll notice that I've got a line of symmetry right here, which goes down. I've got a line of symmetry coming on an angle. I've got one going straight across, and I have one on the diagonal. So that's 1, 2, 3, 4 lines of symmetry on this one. Okay, now what I want you to do is I want you to draw a figure that has only one line of symmetry. All right, only one line of symmetry. And then of course I want to get you get a classmate. If you're in class, I get your classmate to check it. But so I want you to pause the recording. I want you to do this, and then I will draw one that has one line of symmetry. I have to make sure that whatever I draw can't be flipped in any other way except one. So I'm going to put a line in here, and this is going to be my line of symmetry. So there's my line of symmetry right there. Now whatever happens here, I have to make sure that I get both of these able to flip this way, but no other direction. So I'm going to grab some rectangles here. Okay, so here's my first step. I'm going to make in these, right? There's one there. Now this works because that can flip over here, but I could have put a line here to flip on that. So to make that actually not possible, I'm going to draw one here also and put them together. So now I have a compound object which only has one line of symmetry. This side over here will fold to match this side over here. There's no other way to fold it in order to make it work. Now you may feel, oh, well, what if I did something on an angle like this? All right. Well, this has to come straight down 90 degrees. There's nothing here, right? This has to come straight down 90 degrees, and it has to match up with a rectangle, a small rectangle. There's nothing there, so I can't put the lines in those locations. There is the only single line there. All right, now I want you to do one. There's 2 lines of symmetry that we haven't done yet. So pause the recording and do 2 lines of symmetry. Okay, 2 lines of symmetry. Would probably be wise for you to put in the 2 lines of symmetry to work with. All right. Now remember, everything on this side's got to flip to that side, and everything on this side has got to flip to that side. All right. And I can't use a rectangle because I've already seen that. So what I'm going to do is I'm going to create a compound system that will work here. All right. So what I'm going to do is I'm going to take and make this here and this here. I could take this and just copy it and paste it in place, and then it's the exact same object. You don't have to worry about it being out. Now I've still got to make sure that it lines up. Now 2 lines of symmetry. This one here will fold over and match that. This little one will fold over and match that, or I can go sideways, both ways. Okay, I cannot go on a diagonal, but I can do these 2. Okay, the next logical step is to move on to reflections. Now reflections are where we're going to give you one object and we're going to give you the line of symmetry, and your job is to draw the other side. So you're going to be making a reflection just like we did in grade 6 and grade 7. All right, so here we go. This is one here. There you can see my object, and there one over there. Now this object is moving, and that's the way you call the type of reflection it is. This is going from this direction to that direction, or it could be going from this side to that side depending on which one was the original, right? But this is moving horizontally. Think of horizon, right? This one here is moving up or down depending on which was the first, right? So that's a vertical one. And of course, if you're going to come sideways on something, we are going to have what's called a diagonal. And the other word you may hear is the word oblique, which is also a way for saying an angled reflection. All right, so what I want you to do is you've got four letters here, D, G, J, and Q. I want you to pause the recording, and I want you to make a reflection on them. Now remember, each point on this D has to be the same distance from the line as the points on this D. It's got to match up. Okay, so pause the recording and do that. Okay, so let's take a look at D first. This bow right here is the same distance as to there. All right, and this one here, I probably should have put it this way. All right, each one of these is the same distance from the mirror line as the one opposing it. All right, now for G, again, flip it over. You'll notice the distance from this point right here to the line is the same as that distance to the line. The point from here to the line is the same as this one to the line. And they all meet at 90-degree angles. There's our J. And there's our Q. Okay, those were horizontal. Now I want you to do the vertical reflections of 9, 4, 3, and 5. So pause the recording and do these vertical reflections. Okay, so 9 would look like this. Remember, the points all match up. Right? From this point to the line is the same as this point to the line, and they meet at 90 degrees. The middle and the middle meet at 90 degrees, and they're the same distance. The 4 should look like that. Your 3 look like that, and your 5 look like that. Okay, let's take a look at some oblique or some angled reflections, diagonal ones. So pause the recording and draw these. Okay, so this here should look like that. This should look like that. This pentagon should look like that. And this triangle should look like that. Okay. Now I'm not perfect here because I was freehanding everything, but you get an idea. If you were to flip this over, it would match. So doing them on the freehand is difficult. So we're going to move into the Cartesian plane, and we're going to have you work with doing this particular one, and we're going to give you a information here on what the reflection line is going to be. So it says here, reflect the following triangle across the y-axis. Now you have to remember, where is the y? The y is right here. That's your y-axis. There's your line of symmetry on the y-axis. Everything here, it's got to go to equal on there. So if you take a look, it says 1, 2, 3. So A prime is going to be 1, 2, 3. It's going to be right there, right? So the distance from here to there has got to be the same distance as from here to there. And now I've got A right here. There's my dot. Now because this is the reflected image, we call that A prime. Right. Now, the next one is B. Now you count B straight across 90 degrees across your y-axis right here. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So now we count 8 again. 1, 2, 3, 4, 5, 6, 7, 8. All right. So there's my B prime. And for C, 1, 2, 3, 4. 1, 2, 3, 4. There is my new C prime. So I've got from here to there, to there, to there. Okay. Now this is my original, and this is my reflected image. Now the reflected image always has prime marks on it, just like we did back in grade 7 and 8. All right. Now, to see another way of doing it, here is a program that I use quite frequently called Geogebra. And this one does all of these types of things I'm doing. So if you take a look at where the original one, these are the points. There's A is at -3,7, B was at this location, C is here. If I wanted to reflect it, I just got to take and tell it where I want it to reflect across, and you can see it automatically comes over here. Now, take a look at this up here. Since we're going horizontal, the Y value doesn't change, does it? It stays at 7, it stays up this high. The only thing that's different is that I've gone from the left side 3 to the left, and I've gone 3 to the right. So this 3, 7 uses the same magnitudes as this -3, 7. The only difference is on the side of the 0. This negative is on the left of the 0. This one here is a positive, it's on the right. Same thing happens here. This one moves over to here, and then moves over to there, so we have equal distances. And if I slide these around, watch what happens here. If I move this out, look what's happening to the other side over there. If you notice this, it's actually increasing by the same amount. Right? Here's that -8, -2, so I'm at -2 my y, -8, +8. As I go up, you'll see things work. I can even take this all the way across the other side. Now we have what we call the butterfly effect. All right, so here we go. This is what you're going to do. So you're going to be using the same line here. All right, blue this time. I want you to reflect W, X, Y, Z across the Y-axis. So pause that and do that right now, please. Okay, now remember we're going 90 degrees across. So this one here is going to go 1, 2, 3, 4 to get to the line. All right. So then I've got to be able to go 4 more. So that's 1, 2, 3, 4. So that means my new point is going to be right here. And that's going to be W prime because it is the reflected point of W. Now Z is 1, so there's Z right there. And this is primed. Y is 1, 2, 1, 2. There is Y prime. All right. And this is at 8. So it's going to go all the way across to the 8 over here. And that will be X prime. So now I can take the lines and I can join all of my lines together. Oops, I've got arrows on my lines. Give me a second to remove those. Okay, so here's X, Y, down to there, WX. There we go. So that is what you have to do. Now when I'm doing these on tests and stuff, I'm going to ask you to give me the coordinates. And sometimes what I'll do is I'll ask you to do I just give you the coordinates for W, X, Y, Z and have you plot them here, then do the reflection. So here's the other way of doing it with Geogebra. Okay, so you can see I've got W is at 4, 8, right? And if you take a look here, I've got 4 and 8. So I've taken the points, and I told the program to actually keep them in there. So there's W, 4, 8, X, 8, -5. Now if I want to reflect this across the Y-axis, we're going to go to the left, right? So I can do this pretty straightforward on the program. There we go. So there's your reflection. This one here, if I can zoom in, you'll see that it's got a 1 there. So this is 1 to the line, and this one is also 1 to the line. This one is Z, and this one is Z prime. All right. If I grab up here, you can see I've got 1, 2, 3, 4 to get there, and 1, 2, 3, 4 to get there. Notice it's always 90 degrees. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 to get there, and of course 1, 2, 1, 2. Everything, the distances are always the same from the point over to the mirror line. Okay. All right, now this one here, I'm going to be doing the reflection across the Y-axis also. So what I need you to do is take and do the P, which is on the left. It's got to go across the line of reflection. So I'm just going to draw the line of reflection here for you. And you can see this one's going to go right down there. Now, P is going to go across the line. And look over here, Q is also going to have to go across the line. So Q is going to come out here. S is going to go across the line, and R is going to go across the line. So you're going to have what we call the butterfly effect. So I want you to take and pause the recording, and I want you to do this right now. Okay, so taking a look at how to do this. Okay, so here is the diagram in Geogebra, and you can see the P is going to have to go this way, and I've got this on 2 here, so I move in a little bit closer. I can get that to show the 1. So there is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So it's a -2, +8, and that's got to go 1, 2 to the line of symmetry, and then 2 past it. This one's going to move over there, and this one's going to move to the right, and this one's going to move to the left. All right, so I'm going to grab that and do that right now. And there you get your, what I call the butterfly effect. Looks like 2 butterfly wings, and you'll notice that I've got all of these here. -7, 7, 3, 7, 3, 5, -5, -5, -5, -4, 9 to +4. Sorry, -4, -9 to +4, -9. So if you have this correct, and now I was marking this, what I would do is I would have a mark for each one of these points plotted if I had you do the plotting of the original and the reflected image. All right. I'd also give you a mark for putting in the reflection line correctly. All right, going to the next page. Now we're going to do what's called a vertical. Now remember, the vertical is nothing more than just moving up and down. Now my vertical here is across the x-axis, so here is my your line of symmetry. Right here, x-axis. So everything here is going to travel straight across, just like we did when we were going on the y-axis sideways. So pause the recording and do this. Okay, now to find out whether you did it correctly, if you move this down, this is what it's going to look like. All right, now we have the points which were located. All right, I can zoom in a little bit. You can see some of the points here. Now these are all going to go across the x-axis. They're going to go across this, down into this area down here. All right, so you'll notice that I've got my points labeled. This is M, N, O. There's no prime marks because this is the original. To do the actual reflection, there's what it looks like. All right, you'll notice that this is -6, 1. And because we're coming across the x-axis, it's going to be -6, -1. So we'll go 1 to the line here, and then 1 past it. Over here, I've got 1, 2, 3, 1, 2, 3. And the top one, more difficult, but this one goes down 8 to get to here, and then goes a further 8 to get down to here. Notice that I've got my prime marks located on all the corresponding vertices. Vertices is another name for a corner. All right, so that's that one done. Should look like that. Moving on to the next one down below here. I want you to do a vertical reflection, but I want to take it up over the x-axis. Your x-axis is going to be right here. All right, so pause the recording and do that right now, please. Okay, now everything's going to move. So this A is going to move up 2, and then 2 more. D is going to move up 7, and then 7 more. C is going to move up 9, and then 9 more. B is going to move up 5, and then 5 more. So you should end up getting something that looks like the following. Now, to do the reflection, I'm going to be doing it across the x-axis. So this is what I want to reflect across this line. And you can see that I've got, back it up a little bit, you can see that I've got everything lining up perfectly. So this one here, you'll notice is 2, 9. And the only thing that changes is the distance across the x-axis. So this becomes 2, -9. So take a look at this, because sometimes if you're looking for it, for example, if you had an 8, 5 here, and you came down here and you had like an 8, -6, you should be able to take a look at these two and go, wait a minute, there's a mistake here, because I know that the distance to the line of symmetry when I'm using the axis has to always be the same distance. So if this is an 8, that's an 8. This is a 5, that's a 5. The only thing that changes is your negative signs. Okay, let's go to the next one. Okay, here's a butterfly one, and now we're going. You can do this. So it's again, this one's across the x-axis, so there should be no problems here. All right, here's my x-axis. So I want everything above it to go below, and everything below it to go above. So take and do that for me right now, please. Okay, so I'm going to be moving E. It's here, so it's going to be 1, 2, 3, 4. All right. So if it's 4 to get from here to here, I've got to go 1, 2, 3, 4. There is my new E prime. H is 1 up, so H prime is 1 down. Notice the distances here and here are the same. All right. So taking a look through Geogebra again. Okay, now I want to reflect this object here over this line right there. All right. You can see that what I've done here is I've got everything set up so that it goes across the line perfectly. And every distance is the same. You see that this is 1 up from the line of reflection, and this one here is 1 down. All right. This is 7 up, and this one is 7 down. This one is 4 up, this one is 4 down by the negatives. The downs are on the negative side. Same thing happens on this side. Okay, so let's take a look at an oblique one. Now I put your line of symmetry, or your reflection line, right across here at 45 degrees. Now what we don't have here is we don't have a way really to count on diagonals very well. This is exactly 45 degrees, you can count 1, 2, 3, 1, 2, 3, and you can put your A prime right here. So as long as you're going diagonally right across it, it works. So 1, 2, 3, 4 to the line, 1, 2, 3, 4, that's your C prime. B is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and here is your B prime right there. So when I want to draw the lines in here, we're looking at from A to B to C and then back to A. Notice that every one of these diagrams is perfectly 90 degrees across this line right here. All of these are perfectly 90 degrees. Now if you don't have if things aren't at a 45-degree angle right here, what you need to do is start working with some tracing paper. So I'm going to take and just get rid of all this, and we'll go over this again as if we had tracing paper. All right. So the first thing you need to do is to take your tracing paper, and you got to put it down on top of everything so we have room to move this across to here. You need to take and draw on this line of right here, your reflection line, and you got to make a mark right here so you know how far up and down to go. Then mark B, C, and A. Right. Once that's done, then you can take and pick this up, and you take this portion here, you put it over on that side, and you line up the line again, right? And you make sure this little cross goes through the origin here. What that will do is that will bring the A, right, down to well, it's going to be like down to this location. C will come over here, and B will come over there. So let's take a look at the link in Geogebra. All right, so here's what we're going to do here. Oops, sorry. I want to reflect this one over top of that line, and there we go. All right. You'll notice that I've got -6, 6, and I've got 6, -6. Isn't that interesting? 6, 6, 6, 6, 7, 1, 7, 1. Notice that the numbers here, this is now 7, -1, whereas this was -1, 7. So there's some changes that take place in your coordinate pair that if you're looking for, you can verify that you've done things correctly. Right, same thing here. Now, the things you should be looking at is that this here should come straight across 90 degrees. Straight across 90 degrees, straight across 90 degrees. If I was marking this for you, I'd give you 1, 2, 3, 4, 5, 6, and I'd be looking at the C primes to make sure those are done right. Sometimes you give you an extra mark for labeling things correctly. All right, I want you to take and do this one. So pause the recording and do this figure across that 45-degree inclined line. Okay, so let's see how you did here. This W here is going to move that way. This X is going to move that way, Y is going to move that way, Z is going to move that way, and V is going to move that way, and they'll all become their respective primed ones. So taking a look at that, this is what you should have looking at when you're done. All right, I've got my W, which goes to here, W prime. Z comes all the way over here to Z, to X. Sorry, I said Z. X becomes X prime. Y becomes Y prime. Z becomes Z prime, and V becomes V prime. Right. And you want to look at what that looks like in Geogebra. This program is free, by the way. You can download it and put it on your computer all you want. I think there might even be one for your phone. So taking a look at it again, we want to do a reflection of this across this line. There you go. Pretty nice. And it locates and puts in all of our numbers here, so that if I asked you for what were the coordinates of W prime, X prime, Y prime, and all that, you could just write them down in pairs. All right, now we're going to do the butterfly one. So everything on the A here has got to go there, and everything on the B on this side, it's got to go to that side. So pause the recording and do that right now, please. Okay, so let's take a look. B is going to be going right directly across, so your B is going to be out this direction somewhere, straight at 90 degrees. A is going to be over here, C is going to come down this area somewhere, and D is going to be over there. So taking a look at that, this is what you should be looking at. Right. Now notice that the distances are always the same. From here to here is 1.5, and from here 1.5. You notice they're always the same. Now that only works because this is a perfect 45-degree angle. When we get to non-45-degree angles, it's going to be different. All right. Now let's take a look at the next one then. Well, let's go look here. I'll put the Geogebra one up for you to look at. Okay, so I need to take and move this one across this line, and there we go. You notice that your A is -7, 4, and this is -4, 7, so you'll notice that things changing, but the magnitudes are all the same. All right, 2, 6, 6, 2. The magnitude of 6, 2 over here, and 2, 6. These magnitudes, the numbers don't change. The only thing that's changing is the sign. Now that works when you're on a 45-degree angle. Now, you don't always get 45-degree angles, but we're not going to worry about that just yet. We're going to have you just work on your assignment, and we'll pick up some more a little bit later. So complete your assignment. If you're having trouble, come and see me.